We all do things to keep from getting lonely. Some people have friends, some people have family. I have written dialogue conversations with myself in Microsoft Paint. But recently I've been thinking, there's gotta be a better way. And guess what? There is. No, not that. No, I'm just gonna have an AI do this half of the conversation for me. Of course, we could just go type into ChatGPT or something, but first of all, that would be too easy. And it's so cold and lifeless, and it's just missing that je ne sais quoi, which is of course French for I'm a gamer and all of my communication has to be in the form of a video game. So instead, I opened up my favorite game engine, Godot, cracked my knuckles, and got to work. So first up, we need the program to actually be able to read a letter. We'll do this by actually, writing in Godot later, but for now, we just need static images to develop our model. Thankfully, there's a set of test images called the I'm gonna call it the M&M dataset. M&M is a standard dataset of 28 pixel by 28 pixel handwritten letters, and it's used exactly for this kinds of things, like pretty much everywhere. Turns out, back when ChatGPT was still just a funny idea for a plot point in a Kubrick movie, one of the first things the AI got really good at doing was reading handwritten numbers, and eventually letters. This was through a technology called neural networks, which is not really a technology, but actually more of an exercise in marketing to try to make graduate level linear algebra sexy. The way they work is that you take anything, and I mean anything, as long as you can turn them into a list of numbers. Then you send those numbers to each of these little circles, which along the way gets multiplied by some individual number called a weight, and it adds them together, plus a separate little number called a bias. The circle is called a neuron, and the number that you get after multiplying and adding is the neuron's output. Then you send each of the neurons' outputs over here, and depending on what you want the output to look like, you combine them somehow, and voila! Let's try it out! So we open up the M&M dataset so we can try a letter, and why does it look like that? It's supposed to be a B? Oh, what's that? The letters come flipped and rotated for literally no reason? Cool. Thanks, M&M. Anyway, now that that's fixed, let's actually try one. First, we convert each of the pixel values in the letter into a number. We put them into a row. We do our little multiplication trick and see which letter has the biggest number over here at the output. We put in some letters and it guesses... Oh wow, who could have seen this coming? It's complete random garbage. That's because when it starts, all of the weights and biases are completely random garbage, so we need a way to improve them. The way we do this is that we let it make a completely wrong guess, and then we make the whole system more right by taking all of the weights connected to the right letter and making them bigger, and all the weights connected to the wrong letters, making them smaller. And we do this a couple of times, like say 3, maybe 4, maybe several million times. Then we get a much better output than when we started. Alright, so let's see what we ended up with. Oh wow, it still really sucks. When in doubt, we need to go back and change our model. If we take the line and had a whole new line, maybe even a few lines, then we end up with a deep neural network. But now, when we get past the last row, since all the weights are kind of getting all jumbled together, how can we tell which numbers to adjust when we do that little less baddening thing, which by the way is called training? Instead, we have to do this fairly complicated piece of calculus called backpropagation, and that proportions the area accordingly over to the left. I could do a whole video just on explaining how this part works, and I'll keep it short for now by just not. So anyway, let's add a few extra lines for good measure and see how it does, and it still sucks. We have to talk. I don't know how to say this, but the truth is, a picture of a handwritten letter just straight up isn't a line of numbers. When we just grab the pixels in order, we lose so much in here. You'd like the pixels next to each other to be associated together somehow, and you'd really like for the AI to make physical relationships between pixels, like lines and dots. But with this, the network just kind of has to somehow magically figure all that out. But what if there was a better way? But what if we could go to the next dimension? That's right. Now each of these nodes is going to be a little grid of numbers instead of one number, and this time the grid is going to pick a physical location on the image, take those pixels, multiply them all together, and add them. Then, it's going to slide over every single place where it fits and make a new image out of the results. This way, depending on how we configure the little numbers our little grid has, it ends up really liking a certain type of thing. For example, this guy really likes straight vertical lines, and this guy really likes dots. We call the thing that it likes a feature. And the great thing is, we have so many of these little dudes that they all get their own little niche. And even better than that, we can have a grid that goes over the grids that we made, and then a grid that goes over the grid of grids, and we can just keep getting more and more complicated features. So now let's check it out. Wait, it's actually kind of working now. Okay, but hold on. So how did I make this thing Godot, you might be asking? Well, all of the models and the training code and everything like that were written in a Python package called PyTorch. And using this magical add-on that hasn't had an update in over 2 years since Godot 3.5, we can run any Python code we want. Ever. all of them. Nothing could possibly go wrong. Here's what it looks like when Godot is actually training the model. Wow, isn't it beautiful? That's not an image. That's a video. You might be asking, do we have to watch the screen be frozen for 10 to 20 minutes every time we start our game? Of course not, silly. This isn't a Unity game after all. No, now that we train the model, these are just numbers after all, so we can just save them into a file, and then when we start the game, we just have to spend a few seconds loading them into memory, and we can skip the whole training step. I made a bunch of tweaks and tried a few different models. I'll actually link a couple of articles I use for inspiration on the models if you're curious. And by combining their architectures and making some changes of my own, I ended up with a model that's 94% accurate. 94%? That seems pretty low, doesn't it? You're getting like 1 in 20 letters completely wrong. Hey, get off my back, man, okay? Jesus, chill. No, but really, you haven't seen some of the images they put into M&M over here, okay? Like, look at this. This is supposed to be an E. I don't know, it looks like a C to me. And this one guy just had to write completely in cursive, so there's like just enough of these cursive letters sprinkled in to be confusing. I'm like, what the hell is that? It's an X, apparently? Okay, I guess I can kind of see it once you tell me the answer. And oh geez, what the heck is this monstrosity? No, like actually, like, can you try to guess at home? Because to me, it just looks like somebody drew a stick figure in the box. Turns out, it's a G! Okay. and like, the surprising thing is I barely had to look for these. Honestly, the dataset has a ton of terrible images in it, which you'll be even more surprised to hear was probably on purpose. It's actually arguably a good thing. If all of the images were completely pristine and perfect, then when you use the final output of the AI, you'd also have to do your writing pristine and perfect. So when you put in all this like weird garbagey stuff, it actually gets more resilient when your inputs are like relatively terrible. I'm just trying to say, Mr. Strawman audience member, that when even we have trouble guessing what the letter is, it kind of makes that like 94% rate of the AI a little bit better in context, doesn't it? In any case, now we finally have step 1 done, and our machine can read. So the second part of the problem is that we actually have to be able to write in the game in the way the computer can read. Remember when I put this off earlier and just used M&M instead? There are a few ways that I could do this, and originally I was thinking of like spawning separate objects for each pixel and doing raycasts onto them to see if you're clicking on them, but that's like very cumbersome and more than a bit overkill. I also played around a bit with a system that would make an entirely new PNG every time you updated a single pixel, and then in the next frame it would read that PNG into the texture. Surprisingly, it like worked great. You think that writing and reading a brand new PNG every single frame would be super slow? I guess because the image is only 28 by 28 pixels, it's actually not that bad. But this is like lacking in a sort of elegance that I would expect from my code. So instead I opted to do something a little bit less hacky. What I'm doing is I'm just drawing a rectangle, and when you click on it, it draws to the screen. The trick is that the rectangle is actually just a reference sprite. It's just a box that you can see that shows you like the bounding box on the screen. When we click on the screen, you can just do some really simple algebra based on the location and the size of the rectangle to figure out which pixels are supposed to be drawn. And you add that to a list of clicked pixels. And then completely separately, we draw a pixel to the screen, which is actually just floating on top of the rectangle. It's not even part of the rectangle's texture. And then completely separate to the drawing functionality, we have this array of pixels that we send as an input to our neural network. And just one last thing before we get to the neural network, I promise. You may have noticed that in the M&M images, they're not actually just black and white. They have shades of gray around the edges. We want our inputs to match the training set as closely as possible to have the best chance of it guessing. So what I did is I made it so that only the central pixel turns white, and you can add values that are less than 1 to make shades of gray around the central pixel. This not only makes it look more like the training images, but it also has the benefit of making our training images not look like a painting by Ringo Starr. What a dated reference. Anyway. So let's try it out with our 94% accuracy model, and hey, wait, what the heck? It's like, do you see this? It's like kind of like working. Oh wow, that's actually like pretty cool. Honestly, just like writing in the box is surprisingly fun. One thing that you can do is you can kind of like experimentally figure out how it thinks about letters. You can put in like an I, and then you can add a little bit more of a crook at a time until you can figure out how it differentiates between like an I and a J. Oh! We have reached minimum J. I repeat, alarm, minimum J. You can do the same thing with an I turning into an L, which is like, it has to be surprisingly long. Anyway, you get the point. So that's exciting, right? And now with the second step out of the way, and our computer being able to read, we can finally get to the third step, the fun stuff you've all been waiting for. If I have a bunch more of these boxes, we now have an output string, which is whatever the computer thinks we wrote. You can put in as many boxes as you want. I just left it at 12 for now, but anyway, here's the computer being able to read full words and even multiple words if you leave a space. How fun! Just a note on the performance, I was a little concerned that doing 12 predictions every single frame might tank the frame rate, but turns out that even with 12 predictions, we're still running at 240 FPS, which is the maximum that Godot 3.5 gives me, even with the frame rate uncapped. I'm not sure why it doesn't want to run any faster than 240 FPS. But in any case, the good news is the predictions are basically make no performance hit to our game at all, which is like surprisingly great. Anyway, finally, the moment that you've all been waiting for. What is all the fun stuff that we can do? Okay, well, for starters, we can just have it look for certain keywords and respond based on what the keywords are. Oh, wow. What a nice interaction. Okay, that's a little sappy. How about we traumatize our program a bit by giving it the standard Twitter user experience? Oh, wow. That's fun. Okay, let's calm. Okay, that's enough of that. Okay, look, it wouldn't be an AI video in 2024 if we didn't somehow shoehorn ChatGPT in here. And luckily for us, we can take our string and send it to ChatGPT via their Python API. And we can add in a little bit of extra context to see what it thinks of our string. Is it cheating? Yes, but it's also pretty cool. Not to mention that it's the direction that AAA gaming is going if you listen to certain CEOs. So all we have to do is install OpenAI's super simple API library for Python and... Oh yeah, remember when I said that nothing could go wrong when we use our 2-year-old version of Godot so that we can use our 2-year-old version of a critical add-on that makes the whole program run? Well, it turns out that when we want to use that for a Python library for a technology that only came out 1.5 years ago, it doesn't work. That's fine, it's fine. All I have to do to be able to get a nice ending to the video is set up a multiprocessing server on another instance of Python that I have running, open up a universally shared memory buffer that thankfully 3.5 Godot can actually still use, and now all I have to do is be able to write a completely custom communication protocol so that my Godot can ask for API queries, wait for the server instance of Python to fetch a result from the API, and access the results. That wasn't a horribly painful process. No, not at all. But it's only like sort of cheating because we're still using a Python, right? So, you know, games use servers, right? I mean, it's barely cheating at all. Please, Toolman, or however you pronounce your name, can you just like update your add-on? It's so good. I just wanted to work with Godot 4, please. And with that out of the way, we can finally have a ChatGPT version of our traumatized Twitter user reply to our handwritten note in real time. It's basically just like real life. Here's a few more examples. This is voiceover Fred here, just padding for time so I can show off the actual AI a little bit more. This last example is particularly good, but yeah, pretty happy with the interaction between the writing and ChatGPT. Good job, ChatGPT. And once we're already going down the API route, we can do tons of fun stuff. So I'll just give one more example, which is actually a bit of a teaser for the next video I have planned. There's a bunch of APIs for translation, and if we just hook one of them up to our Word, then yes, the AI can read our handwriting and translate to another language. Wowee! Oh, what a sweet thing to say. Thanks, AI. But like I said, once we crack open this like Pandora's box that is APIs or even just like any Python packages, the world is truly our oyster. Even if, like I said, some of them are just a little bit cheating. But what isn't cheating is that, like I said, I've got a follow-up video which is going to take this idea and push it several steps forward and without any APIs or anything like that, no cheating at all. And if you want to make sure you don't miss that follow-up, then maybe you could subscribe to the channel, selfless plug. Leave a comment down below if you have an idea what you think that next video idea that I have might be. It's probably harder to guess than you might expect though. But yeah, if you have any other feedbacks, criticisms, ideas for what I could do in the game, leave a comment about that as well. And as you can probably see, I'm very new and this video took way more effort than I expected. So genuinely, like jokes aside, like it really means the world to me that you watch this all the way through to the end. And it would be a massive help if you could leave a like so that the algorithm actually suggests it to someone other than like my friends that I'm going to personally send this to. And it would be like absolutely massive. It's kind of a lot to ask, I know. If you know somebody that you think might like this video and you can send it to them, it would be like a huge help. Yeah, I hope you enjoyed, maybe even learned something, maybe even got a cool idea for your own game. And yeah, I hope you'll come back for my next video. Thanks again and bye-bye!